Today we're going to talk about compound inequalities. And you already know what a compound word is. Some of my favorite ones are sunflower, sun plus flower, and you get a sunflower. Cup plus cake gives you a cupcake. And here we've got some compound inequalities, which are basically taking two sets of solutions and marrying them together on the number line. Sometimes our solutions overlap, as you see in number 1. That's called a conjunction of sets. So number 1 is a conjunction. And sometimes our sets disjoin. That's called a disjunction. We still have some of the same characteristics that we've already learned about. We see open circles here on line number 1. Remember, the open circles are not inclusive. Not inclusive means we don't include those numbers in our answer. But in number 2, we see solid circles, and solid circles are inclusive, which means that we do include them within our answer set. So what I'd like us to do is think about these number lines. We're going to write down some of the characteristics and we're going to break them down, and then we'll write an algebraic inequality for these particular number lines. So in number 1, here's what I see. I see that 0, 1, and 2 are in the solution set. Now notice that the number line is completely filled in. So not only are 0, 1, and 2 in the number line, but 1/2 is included in this solution set. Maybe we put a point right there. That's 1.9. It's included within this solution set. So, based on the fact that it's an open circle, we can go all the way up to 2.999 and say 2.999 is in the solution set, but not 3. So if we're going to write this as a conjunction, what we've got here is a situation where we would use the word and. This is an and situation. I'm looking for all the numbers that are greater than -1 and numbers that are less than 3. When we use the word and, that creates an overlap of sets, which is a conjunction of sets, which is also known as the intersection of two sets. So if we were to write this as an algebraic equation, x is in the middle, and it's between, but not including, -1 and 3. So x, remember, x represents our answers. Our answers are bigger than -1 and less than 3. This is the conjunction of two sets, and it is an intersection. Let's look at number 2. Number 2 is like two trains going in the opposite direction, a disjunction of sets. So what we can see here is that 8 is not in our solution set. 7.5, not in our solution set. 8.999, not in our solution set. But 9 is in our solution set because the circle is filled. That filled circle shows inclusivity. 7 is in our solution set, and everything less than 7, everything greater than 9, those numbers are in our solution set. Because this is a disjunction, we would use the word or. Our answers exist less than 7 or greater than or equal to 9. That's how we could verbally describe this number line. This is also called a union of two sets. Our answers exist in one set or the other. That's a union of two sets. And we have to write this with the word or when we describe it algebraically. So x is less than or equal to 7, or x is greater than or equal to 9. This is a disjunction of two sets. When the sets are disjoined and going in opposite directions, it is a union, and we use the word or. So let's look at number 3. And in number 3, it's different from 1 and 2. Super easy to see here that every single number on the real number line is shaded in, including the 2 arrows on the end. If we shade the arrows, we're saying that it's going to infinity in the positive direction and that it's going to infinity in the negative direction. And the easiest way to state what this number line is showing is simply to say all real numbers. All real numbers. And symbolically, we can simply say the big funky R. That's all real numbers. Our answers are all real numbers. This next page has a Venn diagram on it, and Mr. Venn was a German mathematician from a couple of centuries ago, and this diagram represents the inequality 0 is less than x, which is less than 10. So, how would this look on the number line? Well, before we get to the number line, let's think about what this Venn diagram is showing. Now, I used the word overlap on the previous page, and we indeed have overlap with this Venn diagram. And we see some numbers within the overlap. That overlap is called the intersection of the sets. And remember, intersection is going to use the word and to describe those values. 1, 2, 7, and 9 are in the intersection of the two sets. 1, 2, 7, and 9 are members of the first set, which is less than 10, and the second set, which is greater than 0. I believe that we could even put some other members in this intersection. So some other members that would live in that intersection if x is essentially between 0 and 10 could be 1/2 or 3.2 or 6 or 7 or 8.25 or 9.99. So truly there are infinitely many numbers that could go in the overlap, but we're just showing a sample of them in the intersection of those two sets. Now, I do want to bring to your attention the fact that 10 is over here, but not over here. Just as a reminder, this symbol is strictly less than. X must be strictly less than 10. Therefore, 10 cannot go in this set. But it can go in the set where it says our answers are greater than 0, because 10 is greater than 0. 100 is greater than 0. 12 is greater than 0. 73, 15, 16, 17, 20. All of these numbers are greater than 0, but not less than 10. That's why they are not in the overlap. Remember, anytime that we see a compound inequality written all together like that with less than, that is an and situation. and both conditions must be met. It's kind of like asking your parents, I want a Ford Mustang that is also red. I want a car that is a Ford Mustang and is red. You want both of the conditions to be met at the same time. This is not an or situation. So when we put this on the number line, because we have an intersection of sets, our number line will be a conjunction. And on the number line, it's going to look something like this. And also just a reminder, when you're drawing a number line, you don't always have to include 0. You just need it to work for your particular situation. So if I need my answers to be between 0 and 10, I'm just going to put 0 and 10 on there. I'll put -5 right here, +5, and then 15. I'm just making the number line fit my situation. This is x is strictly bigger than 0, so I don't include 0. That's why 0 is over here. And I also do not include 10, but my answers live in between 0 and 10. They are bigger than 0, but also less than 10, which is why they are only in the conjunction. And if we were to take this apart, keeping our variable on the left, because that's the way our brains like to look at it, I can take it apart and it means the same thing as that, plugging in that word and. So this is a good introduction to compound inequalities.